Well, you're probably wondering whether you skipped a few videos in the series, but you haven't. This is actually a step quite advanced from where I left off last, but I'm going to go through the steps that got me to here. And what this is me using the FM front end of another radio and coupling that to the various stages of the FM on this guy. So what I've actually done is gone ahead trying to find the FM on this radio, which, as you recall, I wasn't getting. And because I've had numerous problems, and I think, and this sounds ironic, but it's probably true, I think the oscillator on the FM section of this radio is not working either, because I'm getting absolutely nothing. But I am far ahead of myself here. Let me go back and show you how I got to this stage, which is really a, I suppose you could call this a bypass operation, by using the front end of the FM of this radio to test the remaining circuits on that one, so that I could isolate the problem on the FM, and I believe I've done that. So let's go back and I'll tell you what I've done so far, and until we get to this stage. So with all the messing about with the coil in the oscillator that was disconnected, if you recall, we had no oscillator working. We had that coil that wasn't making a good connection. After messing around with that and finding that that capacitor was completely off, we then need to do the alignment. And the first alignment we're going to do is the IF alignment for the AM bands, long wave and medium wave. Now, I know the IF frequency on this radio is 460 kilohertz, and I need to send a signal through the radio at 460 kilohertz, a 460 kilohertz carrier with a modulated tone on top, and I need to adjust the IF coils, or the two IF transformers that deal with the AM, until the signal comes out at that side, and I can then measure it on the speaker and align those coils for the peak output output level on the speaker. So the first thing we need to do is I need to put a signal in there, and the signal will be 460 kilohertz with a 500 hertz tone modulated on top of that. Very low signal. I'll use the adjustable attenuator that I have here. I need to make it as low as possible so that I don't have the AVC affecting the readings. I'll set that up and we'll take it the next step. So first of all, we have the signal generator set to the IF frequency, 460 kilohertz. I'm putting the minimum signal level that I can. Now I'm going to attenuate that further using a variable attenuator that I'll show you in a minute. And the 460 kilohertz is modulated with a 500 hertz signal. It's AM modulation, 500 hertz signal, and I've got a depth of 30%. That should do it. And I then send the signal out through the output of the signal generator. It then comes through this little guy here, which is a adjustable attenuator that I built just to bring that signal lower. At the moment I have set 12 dB attenuation. I can set up to 30 dB. These are cumulative. So I'll start on, call it 6 dB for now, 6 dB attenuation. That signal then comes in and goes into pin 2 of the ECH81 tube, which is where I'm supposed to connect it through an AC coupling. Now this attenuator is AC coupled. So I've connected that in there and we're ready to go on this end. On the other hand, I have the signal from the speaker coming out, and just so that I don't have to blast everybody's ears in here, I have this signal coming out of the speaker. I've got a little amplifier here. This multiplies by I believe it's by 10, by 20 and by 30, so I've got an amplification that I can adjust on there, and all it does is it's taking that AC voltage that it's measuring across the speaker and amplifying it, and then sending it to the voltmeter, or the ammeter, the voltmeter that I have here. So if I turn this all on now, I should hear the tone. What I need to do is I set the radio to medium wave. I set the dial in a position that has less noise, so I don't want a strong station there. And I put up the volume. And there's my tone. Now I adjust the volume to where I want it. It's because it's being amplified. I don't need to have the speaker going full blast and blowing everybody's ears out. But I can now adjust the coils and follow the scale of the meter for a peak reading at a very low input level. Okay, now that is at 12 dB attenuation, 6 dB attenuation. That is 0 attenuation, that's 12, 0, 18, but I'll probably use it on 12. That gives me a good range to work with. Okay, so what I have is 4 millivolts peak to peak carrier signal attenuated by 12 dB that's coming into the front end of the AM radio. So now I need to see what it is that I need to adjust to peak those coils. Let's have a look at that. What we're looking at here is the underside of the IF cans. This is one IF can over here. Obviously it's on the top side of the board. This is the other IF can. Now there's my pin 2 of that coil, of that tube, the input, the first tube. That's pin 2, that's where my signal generator signal's coming in. Now from this schematic there's some instructions at the bottom that tell me that the AM coils are the ones at the top here. Now there are 2 per can. One of them is accessible from the bottom and the other one is accessible from the top. This one's accessible from the bottom and the corresponding one is accessible from the top. Now this one here is the one that's closest to the output tube. So you start from the output and work backwards. So I'll adjust these two, this one and its corresponding top one first for a peak, and then I'll adjust this one and its corresponding top one for a peak as well. So let me do that. I'll set the video on the meter so you can see what effect we have when we start playing with this. We have the volume set, let's call it mid-scale. We set the volume where we want it, just so we can still hear it, but what we're interested in is where the meter is. And we need to adjust these coils, starting with the transformer closest to the output, and I'm going to adjust the top section first of this IF coil. Oh, we've improved it slightly. There's an improvement. Just a slight peak. There's the peak, that's the top. When you go to the bottom, now I'm doing the bottom coil, the one on the underside of the radio. Oh, that's nice. All right, that's a nice improvement. That's been peaked. Okay, so I'm going to the top side of the second, or rather the first IF coil. No, it's pretty much peaked. That's it there. Now the underside, that one is way off. That's a peak. Okay. I'm just going to go back to the other two, the other transformer, and try and improve a little bit. I can drop the volume now back to the middle of the scale. Yeah, just a slight improvement. The other one. No, that's peaked. Right, so our IF, AM IF frequency is peaked. The two transformers have been peaked for the 460 kilohertz IF frequency, and we've basically aligned the IF of the two AM bands. So we're talking about medium wave and long wave. Now for the RF alignment, we are trying to ensure that the reading we have on the scale corresponds to the frequency that we're actually receiving. Okay, so if we look at the two AM bands, we're talking about medium wave and long wave. This sheet, the one with the schematic, actually gives us all that information. So what it's telling us is if you set it at 580 kilohertz, you adjust coil 21 for the oscillator. This is to ensure that it's actually receiving at that position on the dial, and then you adjust coil 15 for the front end for the antenna circuitry. So what we do is we set the signal coming out of the signal generator at 580 kilohertz. We go to 580 on the dial and see if we're peaking at 580 on the dial, see if it's correct. If it's not correct, we adjust L21 till it is correct, and then we adjust L15 for the peak signal. Then we go up to the top end of the dial, but let's do the first one first, the bottom one first. Now what I need to do is I need to move the position that I've got the signal coming in from the point on the pin 2 of that coil, of that tube, I beg your pardon. I'm going to move it to the antenna. Now you're supposed to use a dummy antenna and everything else, but this thing is sufficiently dampened and protected that I don't need to worry too much about that. So I'm going to put that signal into the AM antenna input and look for these two coils, or rather this coil, the two coils, the one that adjusts the oscillator and the one that adjusts the front end, the antenna, and I'll see where we are on the dial. So there's my 580 kilohertz signal coming in. I've set the attenuator to, what is it, 30 dB, so 18 and 12. That signal is going into the antenna. And now we look at the top and see where we are on the dial. I need to set the dial to 580, which is, there's 600, there's 580. I don't hear anything. See if we've lost it somewhere. Where are you? Drop the attenuation a bit. Okay, I can hear it. Oh, there it is. Not quite at 580. So what I'm going to do is I'm going to set it at 580, and I can just hear it, and I can just see a small signal over there. And I'm going to move now I'm going to adjust coil 21 for a peak. There we go. No, too far. That's it. Lower the volume. So our 580 is set. Now if we look at the next stage, it says we need to change the frequency to 1510 kilohertz, and we need to adjust the what I'm doing first is I'm doing the two oscillators first, and then I'll play around with the front end antenna tuning. I don't think those would have changed much. We'll see. So to adjust this to 1510 kilohertz, and I set the dial to 1510, and if I don't find it there, I can adjust it by C39, and C39 is, where is it? It's over there, just above L21. Okay, so first step first, 1510 kilohertz. Adjust the dial to 1510. Set the volume a bit up so we can hear it. Oh, we can hear it already. There's 15. That is as near as damn it. There's 1550. Let me put the volume up. This is what happens when I pass through that point. This is 15. If I peak it, this is where it is. It's as close to 1510 as I'm going to get. So that one's fine. Now what I need to do is I need to check the antenna coils to make sure that I peak them as well. And for 1510, I see in the instructions that it's actually C28. So if I go to C28 and I adjust that, it's improving. There's the peak. 1510. And I've adjusted the antenna coil for 1510. Now I'm going to move it down back to 580 kilohertz. Move the dial down to 580. It hasn't moved, which is good. And for 580, the antenna coil is coil 15, which is the top one there. Let's see if we make any improvement. No, that's peaked. Okay. So, recapping. Lower the volume there. I set it to 580 and adjusted that coil there to get it in line with the dial. I then adjusted that coil to increase the antenna reception. So that is the oscillator coil. That's the antenna coil for medium wave 580. I then went to 1510 and I needed to adjust this capacitor here to get it right on the dial, and I adjusted that capacitor there. That one wasn't necessary because it was spot on, and that capacitor there to increase sensitivity. So that's the antenna section. So that's the medium wave done. Now we've got to go and do the long wave. So back to the helpful instructions. On long wave they tell us to put it on 160 kilohertz signal, and to get it on the dial at 160 we adjust coil 23, and to increase the antenna signal we do coil 18. So that's the oscillator coil, that's the antenna coil. So 23 and 18, that is over there. 23 for the oscillator, 18 for the antenna. So let's see what we have here. We need to set this to 160 kilohertz. Right, and we need to set the radio to long wave, and we need to move the dial to 160. There's 150, there's 160. Volume up. Very faint. Let's drop the attenuation on here. Slightly off. That would be 160. So I'm going to adjust that coil 23. There, that's peaked. Let's put the volume up a bit more so we get more range. So that's adjusted. Very sensitive, this. There we go, that's peaked. And now we'll go to the top one and check the antenna. Oh, we've got a bit of an improvement there. Right. Volume down. So we've done that. We've adjusted the RF alignment. That was the oscillator coil for long wave. That was the antenna coil for long wave. So the long wave is done. The medium wave is done. And we should have much better reception on that now. Let's try it out. Okay, so we've set the radio to medium wave. I've got a small wire antenna at the back, nothing much. Let's see what we get. Now, as I've mentioned countless times before, we have one very weak medium wave station in Madeira. Sometimes, depending on the time of day, we get a couple from the Canary Islands. But this is about what we get on medium wave.
Una de las personas que ha liderado también este proyecto y que se publica ahora en el día de hoy en la revista Nature.
That is the Canary Islands.
Contarnos en qué consiste su investigación. Un saludo.
Now, what we have here, we have the tone controls working. This is the bass and treble. That's a treble knob over there. And the bass, obviously with a very weak medium wave signal, we don't get much. But we also have a couple of other things over here, and one of them is this is a button for speech, and that's probably what you would need to use on medium wave and long wave. This is a bass which I presume will be more present in with FM. There's a hi-fi button which tends to open up the bandwidth a bit, which in this case doesn't help much because we have a very bad station. Now on long wave, as I've also mentioned before, we generally get sweet bugger all. You get all the noises, but no stations. And that too is normal. One other function that I've discovered here, which I didn't know initially, was the ferret antenna has to be activated with this button. So if we go back to medium wave and we try and get that station again, and we activate the Farad antenna, we basically get the same signal but less noisy. Actually, this is a weaker signal. Let's try the other station. Well, it would work in a place that had stations, but what this does is it basically activates the Farad antenna, and because this antenna, see, this antenna is not directional, very little movement on here, you'd actually have to move the radio around till you've aligned it with the best reception on the stations, which is something I don't particularly want to do right now. So that's AM for you. We've got the AM bands done as much as we can. The alignments are done. They're accurate on the dial, in so much as what you receive is on the frequency that's indicated on the dial. The long wave is the same. And now we come to the FM section, which is the biggest hassle of the whole radio, because we're getting, this is what we get on FM. In other words, bugger all. So FM is dead, and that'll be the next challenge, which I started doing already. I'll show you the video of removing the front end of the FM section, the front end of the tuner. And it looks like initially the idea was that perhaps the tuning capacitor is shorting. But only after opening it up can we actually get a better idea. So that's the next stage.